All right.
Cool.
So how do we express that first one in exponential form?
I kind of remember this. We did this a while ago.
Yeah. Hmm.
So you would do log 16 is equal to 4 squared? No.
When you are given a log expression, the way I
Mhm.
convert it in my mind, as long as the log is on the left side of the equation,
Yeah.
is it's the number on the far left raised to the power of the number on the far right equals the number in the middle. In other words, b to the x equals y.
Okay.
So in this case, what does that mean?
Um, so that would mean this would be 4 squared is equal to 16.
You got it. How about number 2?
Cool. And then that would just be the answer.
Yeah. Mm-hmm.
Cool. Okay, cool.
And write your answer like that. 4 squared equals 16.
Okay.
How about number?
The second one would be 3/4 is equal to 81.
Not 3
3 to the fourth
fourths.
power. 3 to the fourth power, my bad.
Okay. And number 3.
2 to the 0 power is equal to 1.
Number 4.
9 to the 1/2 power would be 3.
Uh-huh. And notice the 1/2 power means the square root.
Uh-huh.
That's correct. The square root of 9 is 3.
Right.
Okay. How about number 5?
2 to the minus 3 power is equal to 1/8.
5.
Oh, 5. I'm sorry, I'm ahead. 5 to the minus 1 is equal to 1/5.
Okay. Is that true?
That is not true, is it?
No, it is true.
That is true.
Sure. In other words, 5 to the
Yeah, I
minus
can see.
1.
Turn into a fraction.
That's the definition of it's equal to 1 over 5 to the positive 1.
Cool.
Remember what negative exponents mean.
Mm-hmm.
They don't mean negative numbers. They mean reciprocals.
Right.
Okay, number 6.
Cool. Number 6 would be 2 to the minus third power is equal to 1/8.
Okay, is that true?
It is true.
Yeah.
Yeah.
That's the same as 1 over 2 to the positive 3 power.
Mm-hmm.
All right.
Sweet. All right.
We've done 7, 8, and 9.
Mm-hmm.
The only thing is that you looks like you might have rounded that to 3 decimals, but you've only rounded this to 2 decimals.
Yeah, I need to do that
You
on
have your
those. I just thought
calculator?
that.
You have your calculator in front of you?
It's actually dead. It just died like 5 minutes ago, so it's charging.
All right. You
Um,
need to round.
so
You need to find out the third and probably the fourth decimal.
okay.
In order to
Yeah.
round it, you're going to need to know the fourth decimal. In other words, I don't know if this 9 is correct. Depends on what the next number was.
Right.
Okay.
Okay. Cool.
Evaluate the log without a calculator.
Mm-hmm.
Good. I like what you're doing here. This is kind of what I suggested. I don't know if you got this from your teacher, but
I think I got this from you actually.
probably,
Yeah.
because I'm not sure the teachers teach it this way.
No.
Um, but once you've added the variable like you did,
Mm-hmm.
now it's the same as problems 1 through 6, right?
Right.
In other words, now you
Yeah.
can express it as an exponential. Only thing is x isn't 9. You got 3 to the x equal 27. What does x have to be?
3.
Yeah.
Am I do so? Like I thought, like
Multiplication.
after we. Yeah.
You did multiplication. You assumed that this was 3 times x equals 27.
Oh, okay. That's not the case here.
No.
Okay.
You're dealing with logs. The other side of that coin is exponential expressions. Your
Mm-hmm.
variable is almost always in the exponent.
Okay.
So that's never going to be 3 times x.
Okay.
Okay? So
Right.
x is 3 there.
Mm-hmm.
Here you got 4 to the x power equals 1. What does x have to be?
0.
Yes.
Okay.
Change that one.
Yep.
Here you got 2 not times x.
No, 2 to the x power.
X power equals 1/2. What would x be?
-1.
Good. 13. You got 8 to the x power equals 2.
Mm-hmm.
What would x be?
So x would have to be 3.
1/3.
Or 1/3. Oh yeah, it is 1/3.
In other
Yeah.
words, if I have 8 to the
So,
x power equals 2, well, it can't be 3 because 8
no.
cubed is like 264.
Right.
But if it were minus, excuse me, if
Mm-hmm.
if x were 1/3, what that means is the cube root of 8.
Right.
When I solve for x and I come up with 1/3, that means the cube root of 8, and that is equal to 2.
Okay. 16 through 20, I think I knew how to do. I don't know if that's like the right.
Okay, well, let's go back here.
Yeah, let's get through that.
14 is different. It's unique. Um, here.
Oh, that is, yeah.
Well, but you want to learn these rules. First
Okay.
of all, if I have the log base b of b,
Mm-hmm.
in other words, if my base is the same as my argument,
Mm-hmm.
then whatever that exponent is what it's equal to.
Mm-hmm.
What's the answer to 14?
So the answer to 14 would be 5.
Look at my page.
Yeah, so
B is the
B of
same, right?
B. Right.
In other words, 5 is the base and it's also the argument. So what's the answer?
25.
2/3, the exponent.
Oh, that's okay. So that because they are all the same.
Yeah,
Yeah.
as long as these b's are the same, then
Mm-hmm.
the answer is the exponent. And in this case, that exponent is 2/3.
Okay. Cool.
So now that is strange.
That
That
is strange. Yeah.
because you're going to come up with 2/3 if you divide both sides of that equation by 5.
Oh,
No,
that's
you're
weird.
not. No, you're not.
Oh, no, you're not.
5 and 2/3 divided by 5 is not 2/3. So
Mm-hmm.
this is, first of all, that's the wrong equation. It would
Right.
be, well, you're not going to do it that way. In other
Mm-hmm.
words, we've got an exponential going on inside the logarithm.
Mm-hmm.
So we need to solve 14 by this method right there. We need
Okay.
to know that the log base anything of that anything to the x power is f.
Mm-hmm.
Or if it were x minus 1, it would be x minus 1. It's whatever that exponent is.
Okay.
Okay?
Cool.
Now,
Mm-hmm.
15. Give me the exponential representation of 15.
Okay, so it would be um so log of -1.
Hold on. Translate it to exponential.
Okay.
Same
So it'd
way
be
we've been doing it.
yeah. So it would be 6 to the x power is equal to -6
Minus 1.
or -1.
There's only 3 numbers there. There's a 6,
Oh, that's
minus 1, and an x.
right. Yeah, I meant to say -1. I didn't mean
Now,
to say. Yeah.
solution.
So this would
What
be
can x possibly be to produce a minus 1?
minus
If x is positive, is the answer going to be positive?
yeah.
If x is negative, is the answer going to be positive?
No.
Yes. Negative
Or it can't.
exponents do not mean negative numbers.
They could be both.
No, they're always
Or actually,
positive.
no, they can always, yeah, because
They're
minus
always
times a
positive.
minus.
That's never negative. So this is
Right.
impossible.
Mm-hmm.
And notice that we were
So no
trying to
solution,
take,
yeah.
well, we tried to take the log of a negative number. That's not in the domain.
Mm-hmm.
You can't take the logs of negative numbers. You also cannot take the logs of 0. It would
Okay.
have been just as wrong if I had put 0 in there instead of -1. Well, there's no value for x where 6 to the x power could be equal to 0.
Right.
Just always remember, negative exponents do not mean negative numbers. They mean positive numbers, always. Positive or
Okay.
negative exponents mean positive numbers.
Okay. Sounds
All right. In 16,
good. Hmm.
perfect. Is that a plus sign? Yeah.
That is a plus sign, yeah.
Okay. And 17, how come that sign looks the same as your plus sign in 16?
That's a minus.
Right?
It's supposed to be, yeah, it's supposed to be a minus.
Make sure that you distinguish between minuses and pluses.
Yeah, for sure, because they'll count you down for that.
Well, you can't tell. I can't tell whether that's a plus or a minus. I couldn't
Hmm.
tell whether that was a plus or a minus. You've written the plus too small.
Okay.
There's a huge difference between plus and minus, so make sure you write something that the teacher can figure out what it is you're trying to say.
Okay.
That's a minus because division is going on. I'm going to subtract the logs.
Right.
Okay? Is that a plus or a minus?
For 18 is a plus.
What about the 2 that's by the y?
You don't need a 2 there, right? I got that from the y squared.
No.
Is that
Here's
okay?
the third rule. The first two rules regard multiplication and division. But the
Hmm.
third rule, the log of x to the y power,
Hmm.
I can bring that y down in front on the algebra line. And that's
Okay.
equal to.
Cool.
Okay.
Okay.
So when I expand this, I get
Hmm.
log of x plus the log of y squared to begin with.
Hmm.
And then I can take the 2 and stick it down. So I
Okay.
end up with the log of x plus 2 times the log of y.
Okay.
Is that a 4? Or is it
For which one?
18? It's probably
No.
y.
Yeah, that's a y.
Well, the
Yeah.
only thing wrong with your answer is you need the y squared, and then you need to take that 2 and put it in front. Because when they say expand, they always want you to get rid of the exponents.
Okay.
They always want that exponent put in front of the log of y.
Okay.
Okay?
Cool. Cool.
19, you got multiplication and division going on. So how am I going to write that?
Would it be log of 4 of x of y?
Log, first of all, let's get our terminology. Log
Okay.
base 4
Base of 4
of
x of
x
y.
times y divided by 3. So if I'm going to expand that, what do I get?
Um, say you would get log 4, or log base 4 would be xy.
Well, that's multiplication.
4xy?
No, here.
No.
I'm not doing anything different here. The log of xy is the log of x plus the log of y.
Mm-hmm.
And then we're dividing the whole thing by 3. So now I got subtraction going on, and I'm going to take the log of 3.
Gotcha.
They're all
Okay.
the same base. You cannot do any of these rules of logs unless they're the same base.
Okay.
Okay? So you need to write it, unlike the way I did it at first. But when you have multiplication and division going on, whatever is being
Mm.
multiplied is being added, whatever is being divided is being subtracted.
Okay.
Okay?
Cool.
So 20, yeah, all right.
Yeah.
So, okay, we got 3 things all being multiplied.
Mm-hmm.
So let's separate it first by that. In other words, let's not do all 3 steps in once.
Okay.
So separate it out based on the fact you got 3 things being multiplied together.
Sure. So, let's see. Let me erase it. Okay, so it'd be log 3 of root x.
Let's start out with that, and then we'll worry about radical signs later.
Sure. And then it would be, would it be minus or plus?
What do we got going on? Multiplication or division?
Um, Multiplication, so
Okay.
b plus.
Okay.
Plus log 3 of y
Uh-huh.
plus log 3 of z.
You got it.
Cool.
Now, we're not done
No.
because that radical sign is what exponent?
To cube root.
No, it's a base 3. Radical signs are always square roots if they don't have a number.
Okay.
Okay, and square roots are to the 1/2.
Okay.
Okay, now that we've changed the radical sign to a fractional exponent, I can take that exponent and put it down in front.
Okay.
So here's what I end up with. That's the fully expanded answer.
Okay.
Always take your exponents and bring them down in front.
Cool.
All right. Let's see.
Okay.
How about, we're still expanding. Okay, yeah, we got enough time. Want to make sure we do some condensing also.
Definitely.
But let's look at 21.
Okay. So would this be log 5 of 2 plus 1/2 log of 5 plus x? Or x, not plus x.
Of x, yeah, perfect.
Yeah.
Exactly.
Cool.
Exactly. How about 22?
So it'd be plus log or plus 1/2 log of x. Hold on, sorry. Okay.
Okay.
So 22 would be,
And like I said, you don't need to do the whole thing in one step. You can do it in 2 steps.
okay. So 22 would be log of x squared minus log 4.
Good. And now the second step.
And then
Can't have any exponents in expanded form.
no. So to get rid of that, would be 1/2 log of x.
Not 1/2. Just move the exponent to in front of the log.
Okay, so 2 log of x
Correct.
minus log of
Those
4.
are the same expressions.
Yeah.
Okay. And then we still have the log of 4. All right.
Yeah.
23.
So this would be log of 10 minus log root of x, and then that would simplify to log of 10 minus 1/2 log
Of x.
of x, yeah.
Now what's the log of 10? That's common log, right?
Yeah.
So what is the log base 10 of 10?
Oh, would it be log base 10 of 10?
Well, there's no base.
No.
They don't put a base in there. That means common log. That means base
Gotcha.
10.
Okay.
Okay, which allows you to simplify that further. What is the log base 10 of 10?
1.
Correct. So I can turn that into 1. Whether you have to do that part or not, I'm not sure.
Yeah, I'm not sure.
I don't know if your teacher is going to insist on that or not.
Yeah.
When I
I'll do it
expand, I usually expand as far as I can go without a calculator. And I can do log base 10 of 10. I know that's 1. So I usually make that conversion. How about 24?
Okay, so log 2 of x times y minus log 2z.
Hold on. Oh, you meant, okay, sorry.
Oh, you're fine.
I was
Oh, I didn't see the squared sign. Yeah, so it would be log 2 of x squared y minus log 2z. And then that would simplify to 2 log.
Separate the multiplication first. Don't try to bring down that exponent because that 2 does not belong in front of the log sign at the moment.
Okay.
You can't bring it down until you've taken that y out of there. The y is not being squared. So if I were to move that 2 in front of that, that wouldn't be correct.
Okay.
Okay, so I got to separate these into 2 logs being added first before I can move that 2 down.
Okay.
So it's the log base 2 of x squared plus the log base 2 of y. Hate it when they do that. You know what I hate? I mean, you realize why I hate it? They put in both 2's.
Oh, yeah.
Could they make it any more confusing for a tutor?
Seriously.
Because when I say 2, you don't know which 2 I'm talking about. That's what I hate, when they accidentally make it more difficult to instruct.
Right.
By using 2 and 2. No excuse for that. They could use log base 3 just as easily.
Yeah, definitely.
And now, the final step, now you can bring this 2 down. So you end up with this.
Gotcha.
In other words, you always want to fully expand it.
Okay.
All right. Now let's condense. Now we're going the other way. So 25 is going to be what?
So would it be
a single log expression?
Would it be log 3 of 7x?
Subtraction or addition happening?
Subtraction.
Subtraction goes with what? Multiplication or division?
Division. So it would be log 3 of 7 over log 3 of x?
No, just that. In other words, when I say move it into a single log, when it says condense, it means single log expression.
Gotcha.
That's
okay.
a single log expression. If I gave you this in the previous section, you would turn it into log of 7 minus log of x, right? This is just going the other way. That's all it is.
Okay.
All right. So the next one, 26.
So 26 would be...
Single log expression.
Yeah, so...
inside the parentheses.
2 plus 3. Or no.
What can I do with that 2?
Square it.
Move it to an exponent. Right now it's a multiplier. Move it to an exponent. So that becomes the log of x squared.
Right.
Plus the log of 3. So how can I write the argument?
Log 5 of x squared plus 3. No.
Addition is happening in the expanded version. But when you go from addition and you're condensing, it becomes multiplication. So this has got to be x squared times 3.
Oh, gotcha.
Okay? In other words, keep remembering you're doing the reverse of what we just did. You got pretty good at doing these previous 8. Well, we're just going the other way.
Okay.
Okay? And this does have real applications. There's a lot of log equations where the only way you can solve them is to condense them. So 27 is what? Single log expression.
Yeah. So it'd be...
Parentheses.
Yeah, so it'd be log of 4, parentheses, x to the 4th, or xy to the 4th times 5.
You say log of 4. That's not the correct terminology. Log base 4.
Base 4, yeah.
When you say log of, what's supposed to follow the of is the argument. So it's not correct to say log of 4. That would be log of 4.
Okay.
Okay? So, what goes in the argument? These three things that are being added into three things that are being what in the argument?
Okay. So would it be xy to the fourth power times 5?
Where are you getting to the fourth power? It's just 5x times y. 5 times x times y. The base never becomes the exponent.
Gotcha.
Okay?
Okay.
The only thing that becomes the exponent is a number in front of the log.
Okay.
Then you move it to the exponent. Like this 2 on 26, that became x squared.
Right.
But there's no numbers in front of any of those logs. Okay, how about 28?
Okay. So 28 would be, so subtraction. So we would do log base of 10, parentheses, 1/2 minus 4x. No, 'cause it's...
Okay, do it one step at a time.
Yeah.
We're subtracting two logs.
Right.
So we've got to, first of all, let's do something with this 1/2. In other words, you always want to kind of go in the same order that you expanded.
Okay.
You expanded it, the last thing you did was deal with that exponent, right?
Right.
Now, when you're going the other way, always do the exact opposite. In other words, this, if I want to rewrite it without solving it, becomes x to the 1/2 minus log of 4. Now,
Gotcha.
you should know how to go back to that. What's the single log expression? If this is step 1 of the condensing.
Yeah, so it would be
I'm subtracting two logs. What does that turn into when I condense?
fraction.
Does it turn into division or multiplication?
Division.
Okay, so what goes inside the parentheses?
So inside parentheses would be, would 1/2 to the fourth? Or over 4?
X to the 1/2 over 4.
Okay.
In other words, it's got to be that divided by that.
Okay.
Okay?
Cool.
And 29. So let's do 29 in 2 steps. What's step 1?
Okay. So step 1 would be, to, so,
Move any leading coefficient.
move any, yeah.
So
Move the fraction.
So-
So it'd be log 2 of 2/3.
of x to the 2/3
Mm-hmm.
minus what?
Minus log 2 of y. Or minus, I didn't see 3. It's minus log 2 of 3y.
Y to the 3rd.
Is it,
Remember when you're dealing with logs, that coefficient's the same as if it was an exponent.
okay.
I haven't changed it. At this point, we're still looking at basically what 29 says. Now I can condense it into a single log expression.
Okay.
What goes inside the parentheses?
So it'd be log 2 parentheses, and then it'd be x to the 2/3 over y to the 3rd. Okay.
Real simple. Do those same 3 steps every single time.
Okay.
Okay? So do the first step on 30.
31. Oh, we're on 30. Yeah, so,
I have to run at 8 also, just because I have 8 tonight.
oh, okay. Do you think we could do one example of the change of base formula?
Sure.
Okay.
Where is that? Oh, yeah.
31, yeah.
Change of base is really easy.
Yeah. What did you
It's
say equal to
the
x?
log of the upper number
Hmm.
divided by the log of the lower number.
Oh, I think, yeah.
These bases can be anything you want.
Okay.
It can be
So
log,
it'd be,
common log, it can be natural log, it can be log base 17.
okay,
All
cool.
of those ratios are the same, but it's the log of, I don't mean the bigger number, I mean that's the upper number.
Right.
That's the little number. And I don't mean small, I mean the lower number.
Okay.
That's all you do. So what's 32?
So 32 would be log 2 over log of 6.
33?
Log 0.5 over log 4.
Okay, that's all you need to
Cool.
know for change of base.
Sweet.
Okay, and you need that for certain calculators. In other words, certain calculators only have a common log key and a natural log key.
Mm-hmm.
So if you get log base 6 of 2, you have no way of solving that on a TI-84
Right.
unless you knew change of base, because that becomes common log of 2 over common log of 6.
Okay.
You can get those numbers out of the calculator.
Right. Cool.
Dylan, I will talk to you next Monday night.
All right. Sounds good.
All right.